Okay, let's have a look at question 8. Okay, so question 8 is dealing with derivatives. So it is the first calculus question of the paper. So if you look at question 8, it says determine f prime of x from first principles given that f of x equals to negative x squared. Okay, so we want to find the derivative using first principle. So when you think of first principle, you should think of f of x equals to the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, so how does this work? For the first part, wherever you see an x, you plug in x plus h. Okay, so what do we have? This is going to equal to the limit as h tends to 0. Okay, now my function, but now it's f. We're looking for f of x plus h, so wherever you see an x, it becomes x plus h, so that's minus x plus h squared, minus then just the function itself, minus x squared. Okay, and that's all divided by h. Okay, so now what we do is we continue down with writing the limit, okay, as h tends to 0. Okay, now I'm going to FOIL all that out, so that's going to be minus on the outside. So let's see, there's two of the same bracket, so it's going to be x squared plus 2xh plus h squared, and then I'm going to say plus x squared, and that is all then over h. Okay, so distribute the negative in, that's negative, or the limit as h tends to 0. Please note that you have to keep writing this because you only do the limit at the end. Minus x squared minus 2xh minus h squared, and then that will be plus x squared. Note that this negative does not distribute to that positive x squared on the end. Okay, all over h, so what cancels? X squared and x squared cancel. Okay, and then what I'm going to do is I'm going to take out a negative h, no, I'm just going to take out an h from the these two terms here. So what are we left with? We're going to have the limit as h tends to 0 of h minus 2x minus h all over h. Okay, so the main point of first principles is you want to cancel this h out. Okay, and that's what we've done here. We've cancelled the h, so we have the limit, okay, as h tends to 0 of minus 2x minus h. Now what you can do is from the limit laws is you can do direct substitution of h equal to 0, and then we are literally left with minus 2x minus 0. Okay, just show the step, which equals minus 2x. Okay, and that's your derivative, f prime of x. Okay, so not too difficult on that one over there. If we go to 8.2, it says determine, and then 8.2.1 f prime of x if it is given that f of x equals to 4x cubed minus 5x squared. Okay, so let's have a look at how we're going to do this one. So what we're going to do is we're going to use the shorthand rule or the exponent rule, whichever one you want to call it, but we don't have to go through first principle. So how does this rule work? Well, when you do the derivative, you multiply the front number with, the exponent number with the front number, and then minus 1. Okay, so what are we going to get? We're going to get 4 times 3, okay, equals 12x, and then 3 minus 1 gives you 2. Okay, now we do the same here, minus, so 2 times 5 is 10, minus 1 from the 2 gives you x. Okay, so what's essentially happening there is we have this 3 minus 1 and 2 minus 1, which means we then have 12x squared minus 10x over there. Okay, so just an interesting thing for those of you who want to know, this is a cubic function, so it looks something like this. Okay, sorry, it's positive cubic function, so it's actually going to look something like that. Okay, so the derivative of a cubic function becomes a parabola, and the derivative of a parabola then becomes a straight line. Derivative of a straight line then becomes a constant line. Okay, alright. So 8.2.2 then says d lowercase x, okay, or underscore x, and then they give you the bracket there, -6 cube root of x plus 2 over x to the power of 4. Okay, so this is just another way of writing the derivative. Okay, so remember the derivative can be written as d underscore x, which equals d dx, or which equals to f prime of x. Okay, so all pretty much the same thing over here. So when you have something complicated like this, my best advice to you is first simplify it down to everything, all the variables to have exponents. Okay, so what do I mean by that? We're going to change the cube root of x to an exponent, and then what we're going to do is we're going to take this x to the 4 to the top. So how I'm going to do it is I'm going to do it this way, so d underscore x minus 6. Now the cube root of x is just x to the power of 1 over 3, okay, and then plus 2 all over x to the 4. Now what I'm going to do is, because there's a single variable, or at the bottom, okay, and there's two expressions at the top which are separated by a plus, I'm going to split this into two fractions. So d of x, I'm then going to have minus 6 x to the 1 over 3 all over x to the 4 plus 2 over x to the 4. Now we can simplify. Okay, so remember your exponent rules. If it's divide, we minus our exponents. So I'm just going to write dx again. That's minus 6 x of a third minus 4 plus, and then I'm just going to take this whole thing to the top. So that's 2 x minus 4. Okay, so if we do a third minus 4, let's just work it out on the side. So that's 1 over 3 minus, let's see, that's 12 over 3. So therefore that's negative 11 over 3. Okay, so then it's dx is then negative 6 x to the minus 11 over 3. Okay, and then that's plus 2x negative 4. Now we can just use the short rule, short exponent rule for derivatives, so we don't have to use the first principles. So you're going to multiply this by the front number and then minus 1 off of it. So what are you going to have? You're going to have, let's see, negative, that's positive. 6 times 11 is 66. So therefore we have 66 over 3 x, and now we're going to have to say minus 1 over here, so 11 minus 3, minus 11 minus 3 gives you minus 14 over 3, plus minus 4 times 2, that's going to give you minus 8, okay, x to the minus 5. Okay, and then yes, you can go simplify all of that. So 66 divided by 3 is going to give you 21. Is it 21? No, 22 x to the negative 14 over 3 plus minus 8 x negative 5. Okay, and that's how we go about doing this question. Okay, if you guys are enjoying the content, then please leave a thumbs up on the video. It does help me out a lot. If you have any questions on the following questions, then please leave them in the comment section down below. I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.